بسم الله الرحمن الرحيم. Good evening, students. Today we are going to discuss about measurement of thermal energy. The topic of measurement of thermal energy, and we know that this topic it is topic number 7. This topic number 7 in series of Form 3 syllabus. The contents to be covered under this context are factors that determine the heat content of a substance, specific heat capacity of a substance, and the last one is the change of states. Let us go to start. Measurement of thermal energy. Heat capacity. What is heat capacity? Heat capacity is the amount of heat required to rise the temperature of an object by 1 Kelvin or degrees Celsius. Heat capacity is the amount of heat required to rise the temperature of an object by 1 Kelvin or 1 degree Celsius. If I want to rise the temperature of an object by 1 Kelvin, maybe let's say from 25 Kelvin to 26 Kelvin, or degrees Celsius, let's say from 25 degrees Celsius to 26 degrees Celsius, the amount of heat that must be supplied to that object so as to rise the temperature of that object by 1 Kelvin or 1 degree Celsius, we call it heat capacity. So heat capacity is the amount of heat required to rise the temperature of an object by 1 Kelvin or 1 degree Celsius. The heat capacity is sometimes referred to thermal capacity. The heat capacity is sometimes known as thermal capacity. Heat capacity or thermal capacity is denoted by capital letter C. Heat capacity or thermal capacity is denoted by capital letter C. The bodies made from different materials have the different heat capacity. The bodies made from different materials have got the different heat capacity. Heat capacity of aluminium is different from heat capacity of copper is different from heat capacity of wood, is different from the heat capacity of water. Note, an object with large heat capacity can absorb a large amount of heat energy, but its temperature changes only slightly. An object with a large heat capacity can absorb a large amount of heat. An object with a large heat capacity can absorb large amount of heat, but its temperature changes only slightly. So a body can gain amount of heat, but its temperature may remain as it is. In order for the body to change its temperature, it must absorb a large amount of heat which is equal to the heat capacity of that body. So a body to gain amount of heat, it is not necessarily to change its temperature. It may gain amount of heat, but the temperature remains as it is. But if it will gain amount of heat that is equal to its heat capacity, it will change the temperature by 1 Kelvin or 1 degree Celsius. If it was 25 degrees Celsius, now it will be 26 degrees Celsius. The condition for the body to change its temperature, it must absorb amount of heat that is equal to its heat capacity. Factors that determine the heat content of a substance. Factors that determine the heat content of a substance. Heat content of a body is the energy possessed by a body due to its temperature. Heat content of the body is the energy possessed by a body due to its temperature, and it is also called a thermal energy. It is also called a thermal energy. The thermal energy or the heat content of an object is due to the random motion of the particles that make up the object. The heat content of an object is due to the random motion of the particles that make up the object. The heat content of an object depends upon the following factors. The heat content of an object depends upon the following factors. Roman 1, mass of the object. Roman 2, temperature change. And Roman 3, the nature of the material of an object. The heat contents of an object depends upon these three factors: mass of the object, the temperature change, and the nature of the material. If the body has got the larger mass, if the body has got the larger mass, its heat content of that body is greater. The greater the mass of an object, the greater the heat content of that object. So if we have got two bodies of the same material, of the same temperature, but the one has got the larger mass than the other, the one that have larger mass will have the more heat content compared to the one that has got the lower mass. That means, or that is to say, the river at 20 degrees Celsius and a bowl water or a water on the bowl at 20 degrees Celsius, a river has got the higher heat content. The river has got the higher thermal energy compared to bowl water. Why? Because the greater the mass of an object, the greater the thermal energy of that body. Also temperature change. The greater the temperature change, the greater the heat content of an object. Also nature of material of an object. If the object has got higher heat capacity, it will have higher heat content compared to the one that has got lower heat capacity, provided that the mass and the temperature change are kept constant. So the bodies with higher heat capacity will have the higher temperature change than the body that have got lower, will have the higher heat content or will have the higher thermal energy compared to the bodies with lower heat capacity. Determination of heat capacity. How can we determine heat capacity? The heat capacity or thermal capacity, it is measurable physical quantity. Heat capacity or thermal capacity, it is a measurable physical quantity. It means we can measure the heat capacity of a body. So it is a measurable physical quantity that characterizes the amount of heat required to change the body's temperature by 1 Kelvin or 1 degree Celsius. The thermal capacity or thermal or heat capacity, it is measurable physical quantity that characterizes the amount of heat required to change a body's temperature by 1 Kelvin or 1 degree Celsius. And the heat capacity of the body is given by heat capacity C is equal to quantity of heat required over change in temperature. Heat capacity is equal to quantity of heat required over change in temperature. So that is formula for finding heat capacity. We take quantity of heat required to rise the temperature in 1 degree Kelvin or 1 degree Celsius over change in temperature. Which is 1 degree Celsius now if the temperature changes 1 degree Celsius. So heat capacity will be equal to quantity of heat required over change in temperature. But quantity of heat required or the quantity of heat, it is measured in joules, and change in temperature is measured in Kelvin or degree Celsius. That's why, as we have C equal to Q over change theta, now our SI unit of heat capacity will be joule per Kelvin. So the SI unit of heat capacity is joule per Kelvin or joule per degree Celsius. Okay, it is also expressed in Cal per Kelvin or Cal per degree Celsius, because we know also energy, it is measured in calorie. So that is example 1. In an experiment to determine the heat capacity of steel, in an experiment to determine the heat capacity of steel, 100 kilojoule of heat was supplied. 100 kilojoule of heat was supplied to a block of steel, initially at 20 degrees Celsius. In an experiment to determine the heat capacity of steel, 100 kilojoule of heat was supplied to a block of steel, initially at 20 degrees Celsius. If the final temperature of the block was 219 degrees Celsius, determine the heat capacity of the steel. So we have to determine the heat capacity. We have been given the amount of energy, of heat energy required or supplied to a block of steel so as to rise the temperature. But the initial temperature of the block was 22 degrees Celsius, while the final temperature of the block was 219 degrees Celsius. The quantity of heat Q the quantity of heat Q is equal to 100 kilojoule. The quantity of heat Q is equal to 100 kilojoule. That is first that we have been given. The quantity of heat Q is equal to 100 kilojoule, which is equal, and 100 kilojoule, this K here, K means 1000, so 100 K, it means 100,000. So 100 kilojoule means 100,000 joules. But also we have been given the initial temperature, which is θ1, which is equal to 22 degrees Celsius, while the final temperature θ2 is equal to 219 degrees Celsius. Heat capacity is required. What is heat capacity? What is heat capacity? Solution. The heat capacity of steel is given by C equal to Q over sin theta. We know that the heat capacity C is equal to quantity of energy Q over change theta, which is change in temperature. When I'm switching the values in this formula, when we switch our values in this formula, it will be like this. A heat capacity will be equal to 100 joules over 219 degrees Celsius minus 22, not 219, minus 22 degrees Celsius. Here we have 100 joules over, when we take 219 minus 22 degrees Celsius, we get 197 degrees Celsius. When we divide 100 degrees Celsius, 100,000 joules divide by 197 degrees Celsius, we get 507.61 joules per degree Celsius. That is, so therefore the heat capacity of steel is 507.61 joules per degree Celsius. Up to here, we have already covered the first part of this topic. We have already covered the first part, which is factors that determine the heat content of the substance. Inshallah, in the next session we are going to discuss about specific heat capacity